curvature of the stomach. And it's going to be kind of a retroperitoneal organ, and it's going to kind of also kind of crash into your duodenum. So a nice little picture of it in the following slide. All right? We can also get from the picture the three different regions of our pancreas. We have the head tucked up against the side of the duodenum. You have the body, which goes along the side of the stomach, and then the head of or the tail kind of follows the upper part of the greater curvature. They just kind of straighten it out for us to sort of see. But I can see that there's the tail, there's the body, and there's the head of the pancreas. I know that the pancreas from tonight's lecture creates buffers like bicarbonate ions and all kinds of pancreatic enzymes. And do you remember the hormones that come from the pancreas?
Yes.
Okay, fine. What are they?
Insulin and
Insulin and which cells produce glucagon?
Alpha cells.
Alpha, beta,
then beta,
zeta. Okay. Alpha cells produce glucagon. Okay. Now, our pancreas is divided into little sections called lobules, and a lobule will consist of a pancreatic duct, your Acini cells, and the pancreatic islets. You guys more recognize them as the Isles of Langerhans. Now, of these two, which one's endocrine, or are neither of them endocrine?
The Isles of Langerhans.
Isles are endocrine, right? The Acinis are exocrine structures. And we should have that already down in our little noodles.
Do you care what we call it?
No, you can do either pancreatic islets or Isles of Langerhans. So let's take a look on the inside of our pancreas, and it kind of looks like this. Imagine you're doing an aerial flyover of a neighborhood, and these are houses, and there's a little cul-de-sac. So these are all the houses are Acini cells, right? And I know that it's the definition of exocrine because they release their substance into the lumen, right, which then goes through a duct that leads to the surface of a structure. This will actually lead to the surface of the inside of your duodenum. So it is an exocrine definition. I have the Acini and I have the duct. The yellow cells are part of your pancreatic islets or your Isles of Langerhans. You can see the capillary right in the middle of them. So I can see that a lot of my pancreas is comprised of exocrine tissue, and then spaced kind of sporadically throughout are my regions of endocrine function with those. The enzymes we realize are pancreatic lipase, pancreatic alpha amylase, and proteolytic enzymes. Remember, you must always use the full name. Don't just say lipases and amylases because they're all different kinds, and we need to know you know which one it is. All right, your liver. There's 4 lobes, but from the anterior view, you can only really see 2. And what's an easy way of always finding the right lobe? Bigger? Nah, that's not a good thing. Never use bigger. Never go downwards. What do you mean downwards? What's that? Yeah, what's that green thing right there? It's always on the right lobe. You find the gallbladder, you found the right lobe. That's a nice landmark to look for. We can separate our lobes with 2 ligaments, the falciform, which is more like a sheet, and then the round ligament, right through there. And those are remnants of your umbilical cord structures.
No way.
Oh, yes way. They just dry out like your adductus arteriosus, shrivels up into a ligament, right? This is what the part of your connection to mom to get nutrients. Go to the back side of the liver. You get this. All right. Again, easy to find the right lobe because what can you find? Find the gallbladder. I know that's the right. Even if they didn't have the words there, it's easy. But the other 2 smaller lobes, you have the caudate and the quadrate. Nobody say anything out loud, but figure out what can you use as landmarks to be able to identify and define the caudate versus the quadrate. What would you use to figure out what in the hell which is which? Right, so what would you use to find the caudate? Isn't it next to the inferior vena cava?
Yeah.
Isn't it between the falciform ligament and inferior vena cava? Forming a little finger tail-like projection, hence caudate, meaning tail. That's what I would use between the falciform ligament and the inferior vena cava. And the same idea down here, but now I'm going to use the gallbladder and the round ligament. I mean, find something for you that you can use to go, here's the boundaries of this thing. If I find those things, I can find the region. Rather than somebody going, oh, that's a cod egg. How do you know? I don't know, I just know that it's a cod egg. Find a reason why you want to call it what it is. In case you have a brain fart, your brain can go, is it between the falciform and the gallbladder? Yeah, then dummy, it can't be a cod, it has to be a quad. We can also see a part of your hepatic portal vein here and a part of your hepatic artery. Blood's going to be coming in through both of those, going into the liver. They'll be exiting through your hepatic veins. And realize what the hepatic vein drains into. This nice big inferior vena cava. Well, we kind of talk about the inside of your pancreas. Let's do the inside of your liver. It has little lobules as well, known as liver lobules. About 100,000 of the little buggers. And they're separated by the interlobular septum, which is easy to remember because inter means between, so between the lobe wall, between the lobe septum. Now, what is inside of a liver lobule? Well, hepatocytes. Hepato for liver, cyte for cell. These are your liver cells. And then things called sinusoids, whatever the heck those things are. You guys recognize the name sinusoid?
Yeah.
Yeah.
What are they?
They're like the little capillaries.
There we go.
Little capillaries?
Oh, the
Okay.
capillaries
are the holes in
Are they
it.
permeable?
They have gaps in them.
The super permeable.
They're very.
Right, remember you have,
Yeah.
do you guys remember the 3 different types of capillaries? You should.
Yeah.
Continuous, menstruating, and sinusoidals. These are the ones that I said are only found in the liver when we did the blood vessel discussion. You know, making connections and shaking cobwebs. Let's look inside of your liver. It'll kind of look like this. A lobule is a 6-sided hexagonal structure. There's one lobule here, another one, another, and another, and another. On the corners of my lobules is a structure called a portal area that I recognize as having a blue thing, a red thing, and a green thing. Okay. We'll get to the colors are in a second. All of these little brick-looking like things are hepatocytes.
Whoa.
So if we zoom in on what this looks like from a closer view, we get this. Now we can name the red thing, the blue thing, and the green thing. The red thing is a branch of your hepatic portal vein. You've only got one hepatic portal vein going into the liver. This thing is branching thousands and thousands and thousands of times.
Blue thing or the red thing, did you
The blue thing, where it says hepatic portal vein. And then the red thing, right, is going to be a part of your hepatic artery. Again, there's only one artery going in, but it branches and branches and branches and branches. So I realized that this pattern of a branch of the hepatic portal vein and a branch of the hepatic artery is what I find in every portal area going around my liver lobules. So I look at this one portal area, I realize it's kind of servicing 1, 2, 3, 4 separate lobules. They're quite busy little structures. So I realize that the hepatic portal vein is bringing blood from the intestines into the liver. So these are your sinusoid capillaries. And there's this alien living inside of your sinusoids called Kupffer cells. They live in the sinusoid capillaries. They are highly phagocytic. They will eat dead cells, toxins, heavy metals. So you got dead cells, toxins, which is a heavy metal. Heavy metal is a toxin.
Are they more phagocytic than macrophages?
Probably not, no, probably similar. They're just more tolerant because they can eat things like arsenic, mercury, cyanide and such. Now the blood's going to pass up through the hepatic portal vein, right, go through the sinusoids, so kind of bathing the Kupffer cells in that blood, which is why they're able to, or be quite convenient in eating toxins and pathogens and such. Then it'll drain into this big central vein, because the central vein is the vein in the center of the lobule. So all of these sinusoids are converging onto these central veins. We also have the hepatic artery that's going to be feeding the hepatocytes. They need to eat, they need oxygen, glucose, and get their metabolic wastes taken care of. But again, the flow is in the same direction. They'll actually merge with the sinusoid so I can drain into the central vein. Does anybody remember the hydrostatic pressure in systemic capillaries on the arterial side? Really? You were going, yeah.
Oh, 35.
Okay, 35 millimeters of mercury. What's the hydrostatic pressure inside of a glomerulus? 60. So I remember the glomerulus was a high pressure capillary. This is a low. It's lower than 35. Right? Because I need a reason for the blood to come in here. And blood always goes where? To regions of lower pressure. Right? So this is a really low capillary bed. Now you have your little your little hepatocytes here, and they're cranking out as much bile as they possibly can. And what is that bile going to drain into? Bile canaliculi. That term should sound familiar.
I was gonna say it looks like canaliculi.
Like what?
They look like canaliculi.
What are canaliculi?
Yeah.
What are they?
They're in the bone.
Yeah. Remember, they're generally just passageways for the cytoplasmic extensions of osteocytes. Well, these are just like the same basic idea. So hepatocytes make their bile, it enters into the bile canaliculi, which will drain in the opposite direction into a bile duct. So we kind of step back, we realize that it's like a big plumbing system for a multi-story complex, right? I've got water coming in, I've got sewage coming out in a sense. Right? All these bile canaliculi converge onto the bile ducts, right? And we're not going to worry about bile ductules, but the bile canaliculi go to the bile duct. I've got a branch of the hepatic portal vein going this way, a branch of the hepatic artery going this way, and all of our bile from all of these bile canaliculi and all of these bile ducts are going to merge and leave the liver for just two passageways. It's going to leave through the right and left hepatic ducts. There and there. What happens when the left and right merge together? We form a common pathway because we go from 2 to 1. So this is a common pathway. Stuff that was in here is now going to be in there. Stuff that was in there is also going to be in here. So let's call it the common hepatic duct. Keep in mind, whenever you see the word common, that means probably either two things merged to form it, right? Like your internal and external carotids came off of the common carotid, right? The common iliac with this. So the bile from the right side of the liver drains in from the right hepatic. All the bile from the left side of the liver will go into the left hepatic and then joins to form a common hepatic duct, which will then merge with another duct called the cystic duct. So when you join the cystic with the common hepatic, and I'll get a common bile duct. Realize this is a common bile duct, not the same as a bile duct. Right? This is a common bile duct. And the common bile duct will come down here and empty into our duodenum like we saw in tonight's lecture with CCK hormone. When your sphincter is closed, right, the bile will back up, go through the cystic duct, and I can store it inside of my gallbladder. It holds about 70 milliliters of bile. And remember, the gallbladder does not make the bile. We now know what makes the bile, right? It's those hepatocytes. So I can store it in here when I need large amounts of it. We get down to see where the common bile duct joins up with the pancreatic duct, which is why the sphincter is called the hepatopancreatic sphincter, because I'm getting an extension from the hepatic region and the pancreatic region, and that smooth muscle sphincter is a hepatopancreatic sphincter, otherwise known as the sphincter of Oddi. And if you know Garfield, you know who Odie is. And that's why it got its name. The guy liked the dog cartoon. That's where it got its name. Sonic Hedgehog got its name from a game. Okay? Oh crap, I should add more notes.
I think you're
All right, ladies